Hey everybody, this is the greenhouse effect. We're going to look at learning target number 3. The first thing I would like you to do is to make a prediction. Is the greenhouse effect good or is the greenhouse effect bad? Okay, so what is the greenhouse effect? The greenhouse effect, if you've ever seen a greenhouse is a glass building and it's used for growing plants. And the idea behind a greenhouse is that the sunlight comes in through the glass, and when the sunlight gets reflected back up towards that glass surface, it gets trapped in there. And so it traps in the heat, and so you can grow plants in the wintertime and keep your plants safe all year in these greenhouses. Maybe you've seen one at like Paul's Market. So it traps in the heat. The sunlight is allowed to come in, but it traps the heat with that glass surface. So we have these gases that we call greenhouse gases that do the same thing. They allow the heat to come in, but it traps it when it tries to escape. So greenhouse gases absorb heat that's reflected by the earth, and they trap it in the atmosphere. So the greenhouse effect isn't necessarily a bad thing, but too much or too little of it can be. So if we have too little greenhouse gases, we don't have enough heat and we wouldn't be able to survive. We would be in an ice age. We just wouldn't be able to survive very well without any greenhouse gases at all. If we have too much greenhouse gases, we get an extreme heating situation where it traps too much heat and the temperature would just become too much. Okay, so common greenhouse gases would be gases like carbon dioxide or CO2. We've talked about that one a lot. Methane gas is a strong greenhouse gas. It's CH4. And then water vapor, just water in its gas form, is also a greenhouse gas, and that traps heat. Okay, so if we were to draw the greenhouse effect, what it looks like, I'm going to just draw a little sun up here. Okay, and what happens is the sunlight comes in, it hits the Earth's surface, and then it gets reflected back towards space. But what happens is these greenhouse gases, like carbon dioxide in the atmosphere, they trap those gases and they bounce back in. And so it keeps the heat inside, just like a greenhouse would. So we get this greenhouse effect. All this heat is trapped. Okay, so if you notice in this picture, here is different greenhouse gases, and the majority of the greenhouse gases are carbon dioxide. We have some methane, some nitrous oxide, and other gases, but the majority of it is carbon dioxide. We release a lot of carbon dioxide into the atmosphere through the combustion of fossil fuels. So carbon dioxide is not a strong greenhouse gas. It's actually a pretty weak gas, but it's just the immense amount of carbon dioxide makes up the majority of those greenhouse gases, or that greenhouse effect that we see. Okay, so here's an example. It says, what does the amount of CO2 tell us about temperature on other planets? Well, if we look at these 3 planets, here's Mars. It's got a very thin atmosphere. Almost all the CO2 is in the ground. There's no carbon dioxide or greenhouse gases in the atmosphere. It's got a temperature of minus 50 degrees, very cold. Here's the Earth. 0.03% is carbon dioxide in the atmosphere, and we have an average temperature of about plus 15 degrees Celsius. Here's Venus. It's got a thick atmosphere. 96% of the atmosphere is carbon dioxide. A lot of greenhouse gases. Average temperature 420 degrees above zero. So we can see how that CO2 plays a direct role in how hot the planet is. So go ahead and answer that question on the side of your paper. Okay, So history of CO2 trends. So this is a graph showing the amount of CO2 in the atmosphere over the last 800,000 years. And what we see is that it's fluctuated. It's gone up and down over time. It goes up, it goes down. Very, very kind of up and down of a trend. Okay, where we get this data is from the ice cores. When we drill into the ice in Antarctica, when we pull that up, we can look at the bubbles that are trapped inside the ice, and we can actually analyze those bubbles, and that tells us how much CO2 is in the atmosphere at that time when that ice was created. And so that's where we get this data from, is from ice cores. Okay, now due to the greenhouse effect, the amount of CO2 in the atmosphere and temperature are directly related. We see how in this graph we see the blue line and the red line, how the temperature follows the amount of CO2 in the atmosphere. Okay, one thing to notice is over the last 100 years or so, we noticed that the CO2 levels have really drastically increased. Okay, so based on what we know about the greenhouse effect, is CO2 and temperature a causal or correlational relationship? Does CO2 cause the temperature to rise? Okay, here's one more graph I'm going to show you. Here's the trend after the Industrial Revolution. So the Industrial Revolution is when we started using oil and fossil fuels for factories and cars. This is the CO2 level over the last couple hundred years. So if this is what's happening to the carbon dioxide levels, what would you predict is going to happen to the temperature? Okay, well that's it for learning target number 3.